Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck, and today we're looking at episode 3 of our proof series. Today we're going to be looking at some bigger, more complicated proofs, and I'm going to show you how flowchart proofs can help you simplify the structure of your proof and make it easier to see what you are doing. Let's get started. Theorem in our video today. This is the vertical angle theorem. Some of you already know it, and what it says is that vertical angles, which are angles that are across from each other intersecting lines, are always going to be congruent. And we're going to prove that today. So let's see if we can follow the same process that we learned in our previous videos and see if we can apply that here. First thing that we need to do is understand what it's asking, and this one is very simple. Angle 1 is congruent to angle 3. Remember, congruent means same size and same shape. That just tells me that I need to prove that this one and this one are equal or congruent. Now, the second thing that I want you to do once you do that is to look at your diagram and see how you might go about solving that. Think about the process. What exactly is going on that makes it true? Now, if I look at this one, I can see here is kind of visually that 1 and 2 are what we call in geometry a linear pair. Linear pairs mean that they form a line and that they are supplementary. So supplementary means they add to be 180. Now here's the cool thing. If you see that those two are supplementary, they're a linear pair, you can also see these two are a linear pair. And you can see that that 2 overlaps. Now, one of the things I suggested in our last video is to plug numbers in to help you visualize what's going on here. So let's just pick a number for angle 2. It looks like an obtuse angle, so I'm just going to say this looks like it's about 120 degrees. Now, if angle 1 is supplementary to 120 degrees, that means it must be 60 degrees because it has to add to be 180. But if we look at angle 3 is also supplementary to angle 2, which means it also has to be 60 degrees. And you can see by plugging numbers in here, you can see what's going on. All I need to show is that these two are both supplementary to the same angle, which means that they have to be congruent. I am going to show you how to do this proof. There are other ways of doing this proof, actually shorter ways of doing this proof, but I think this one is going to help us continue to build our proof building skills. Before we get started, I'm going to show you a slide that shows you the types of things that you should be remembering in order to solve a proof of this type. If you have all of these already in your head, feel free to fast forward. Otherwise, you should probably get these in your notes. The first one is the definition of a linear pair. And these two things, it just means that there's two angles that are on the same line. The linear pair postulate is slightly different. It says that two angles that are a linear pair are supplementary. I hope you see the difference. One tells you what something is, one tells you the property that they are supplementary. Supplementary, of course, the definition of supplementary tells you that they add up to be 180. If you have these three things in your head, you're going to be in good shape here. The other relevant ones that you're going to need to remember are from our previous videos. There are ones about the definition of congruence. That allows you to switch back and forth from inequality or from equals to congruent. And the other one is substitution. Now, substitution allows me to replace one equal thing with something that it's equal to. All right, let's go ahead. Now that you have that, let's get started on this one. The first thing that I need to do is start getting to the point where I can show that these two angles, again, I made up these angles, so I'm going to erase them now. But I want to show that angle 1 and angle 2 are in fact supplementary, so I need to go starting about doing that. The reason I know they're supplementary is that they are a linear pair. So I'm going to start with that. Angle 1 and angle 2 are a linear pair. I'm going to go ahead and put that up there. The reason that it's a definition of a linear pair. The definition of a linear pair, that just says that that's the shape of them. All right? The next thing that I want to write down is that angle 1 and angle 2 are supplementary. That's what the linear pair postulate says, what I just put you on that slide. So that's going to be the next step. And thirdly, once I know that they're supplementary, I need to write down what does supplementary mean. And it means that angle 1 plus angle 2 are equal to 180, and that's the definition of supplementary. Notice again, as I wrote this down, I used the letter M to discern that I'm talking about how many degrees the angle is. It stands for measure. Okay, and that's the definition of supplementary. Now this looks really tedious, but remember, we're writing a map and we need to have every single turn on our map so that people don't get lost. They're a linear pair, that's the shape. They're supplementary, that's the linear pair postulate. So obvious I can't prove it, that's why it's a postulate. And what does that actually mean? That means that angle 1 plus angle 2 is equal to 180. These 3 steps are going to show up a lot in many different things, so you might get used to writing them down. So I've written all this down, and what I've shown, again, all I've shown is that these 2 add to be 180. I still need to show that these 2 add to be 180 in order to show that angle 1 is equal to angle 3. And this is going to get really tedious because I have to write all these again, and the only difference is that I'm using angle 3 instead of angle 1. That's the only difference here. And this is where the strength of the flowchart proof that I'm going to show you really comes in. Instead of writing everything down in a big list, and it's actually hard to see how it relates, the flowchart proof actually helps you to show the relationship in a diagram. So let me rewrite this, and I'm going to show you why the flowchart proof is a better option for this particular proof. All right, I've rewritten this in a flowchart. Now, for those of you who know what flowcharts are, it's simply a diagram that shows you the order that things go in. My favorite flowchart of all time comes from XKCD. I'm going to show you a picture of it right now. I'll let you pause it and read it, but it's really funny. So that's a flowchart. And we're going to be doing the same thing here. Now again, my whole goal is to show that angle 1 is congruent to angle 3. And I'm using angle 2 to do it because these are both supplementary to the same angle. So look at this. If I have this whole group and this whole group right here, they can both be pointing to the same idea. They can both be pointing to this one. If both of these are equal to 180, then they're equal to each other. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. Okay, both of these have led to this since they're both equal to 180 degrees. Now, my justification for this, if you watched the last video, if I'm doing multiple substitutions at once, it's going to be the transitive property of equality, because I've substituted more than one thing in here. I've replaced 180 in this diagram, right? These 2 add to be 180. I've replaced 180 with what 180 equals to. So that's right here. So my justification for this one is just going to be the transitive property of equality. And with a flowchart proof, you can put your reasons anywhere you like. On these 2, I've put them on the side. On this one, I'm just going to put it underneath. So we'll put it right here. The transitive property of equality. Now, I'm getting really close. So I've got the transitive property of equality, and I see here that I have the same thing in both of them. I'm going to subtract that from both sides. So I'm going to go ahead and subtract the measure of angle 2 and the measure of angle 2 from both sides. And that's going to lead me to my next point. Again, that one is the subtraction property of equality. Again, we have an equal sign, so that means I can use all of those properties. The subtraction property of equality is my reason. And again, you can show, you can put your justification, your reason wherever you want. I'm just going to put it to the side here, which leads me to one of my last pieces. I now have the measure of angle 1 equals measure of angle 3. And what I need to show is that these two are congruent. So the last step that I'm going to write down is that these in fact are congruent. I'm going to say that angle 1 is congruent to angle 3. And remember from the last video, if you want to change equals to congruent or congruent to equals, your justification is the definition of congruency. Okay, so you can write that one in right here too. And at the very end of your proof, you can write QED. Now, I like the flowchart proof because it allows me to see, hey, this whole thing right here and this whole thing together, they combine to this really important step. Now, once you have that important step there, you're in great shape. So this is going to be, again, a big proof, but remember the process. Start with what is the problem asking, draw in your diagram, then ask yourself, how am I going to get there? You're writing a map. Once you get that destination in mind, we're going to go through all the steps and you're going to be very specific. You're going to tell me every turn until you get to the final end where you have reached your destination. All right, I'm Mr. Calbeck, and this has been another episode of our proofs. I will continue to put proof examples up as we get more in the future. Please let me know in the comments if there's any other kind of proof that you'd like me to do a video on or something else entirely. Thanks very much. We'll see you next time.